Fascinated by the technical achievements of the Egyptians.
In the Clarendon lab in Oxford, where physicists keep a battery with the longest battery life the world has ever seen. It powers the Oxford electric bell.
It's shock because anything from ancient Greece simply shouldn't have gear wheels.
Technology so advanced, yet lost forever, inventions that vanished without a trace and continue to baffle scientists today. We reveal the top 10 lost inventions humanity can't recreate, unlocking mysteries that challenge our understanding of history and innovation. Ancient secrets remain hidden, waiting to be rediscovered. Greek fire. Greek fire was a legendary incendiary weapon used by the Byzantine Empire during naval battles, unknown for its exact composition today. This substance could ignite on contact with water, making it incredibly effective for repelling enemy ships. Historical records describe it as a liquid fire that burned fiercely and was deployed through siphons or catapults. The formula for Greek fire was a closely guarded military secret, lost over centuries due to the fall of Constantinople and the destruction of Byzantine archives. Modern scientists and historians have attempted to deduce its ingredients, suggesting mixtures of quicklime, sulfur, and petroleum derivatives. However, no one has perfectly replicated its unique properties and deployment techniques, leaving much of its actual chemical nature a mystery. Greek fire's strategic advantage shaped medieval warfare and demonstrated the sophistication of early military technology. This lost invention embodies how knowledge can disappear, shrouding past innovations in secrecy that continue to fascinate researchers worldwide. Antikythera Mechanism. The Antikythera Mechanism is an ancient Greek device often called the first analog computer. Discovered in a shipwreck off the coast of Antikythera, it dates back over 2,000 years and was used to predict astronomical positions and eclipses decades in advance. The mechanism's intricate system of gears and dials demonstrated highly advanced knowledge of astronomy and mechanical engineering far ahead of its time. Researchers initially struggled to understand its purpose, but modern imaging technologies revealed its function as a sophisticated calendrical and astronomical calculator. What remains puzzling is how such a complex machine existed in an era when similar technology wasn't thought possible. The craftsmanship and precision engineering required are beyond what was believed achievable in the ancient world, and no equivalent device has been found from that period. Roman concrete. Roman concrete, or opus cementitium, is a construction marvel that has resisted the elements for over 2 millennia. The durability and longevity of Roman structures like aqueducts and the Pantheon stem largely from this unique material, which included volcanic ash, lime, and seawater. Unlike modern concrete, Roman concrete actually strengthens over time through chemical reactions with the environment. Scientists have studied its microscopic structure, discovering that the volcanic ash created crystals that helped repair cracks naturally. Attempts to replicate such resilience with today's materials have fallen short. Modern concrete deteriorates faster, particularly in marine environments. The exact mixing techniques and proportions used by Roman engineers remain partly unknown, as the methods were transmitted orally or recorded in lost treatises. Rediscovering Roman concrete's secrets could revolutionize modern construction, especially for durable infrastructure exposed to harsh conditions. This forgotten recipe highlights how ancient innovation still holds valuable lessons. Damascus steel. Damascus steel swords and blades were famed in the medieval world for their combination of strength, flexibility, and distinctive wavy patterns. Produced by blacksmiths in the Near East, this steel was known for its sharp edge retention and resistance to shattering. The exact method of forging Damascus steel vanished centuries ago, partly due to lost knowledge about the raw material known as Wootz steel, a high-carbon crucible steel imported from India. Attempts to recreate the legendary blades have been hindered by the rarity of original ore, specific temperature controls, and the intricate forging process involving repeated folding and layering. Modern metallurgists use powerful microscopes to analyze surviving samples, uncovering nanostructures responsible for its unique mechanical properties. However, replicating that combination consistently remains elusive. Damascus steel's mysterious production process symbolizes the peak of pre-industrial metallurgy and continues to captivate scientists exploring the boundaries of ancient craftsmanship. Stradivarius violins. Stradivarius violins, crafted by Antonio Stradivari in the 17th and 18th centuries, are widely regarded as the finest string instruments ever made. Their unparalleled sound quality, richness, and projection remain a mystery to experts. What exactly gave these violins their distinctive tone, wood type, varnish composition or construction techniques is still debated. Stradivarius' secret methods died with him, and even with advances in acoustics and materials science, modern violin makers cannot fully replicate his instrument's sound. Some theories focus on the aging of the wood from specific regions during a climatic period known as the Little Ice Age, which may have altered the wood's density and resin content. Others investigate the unique chemical makeup of the varnish, contributing to sound enhancement and protection. The instrument's exquisite craftsmanship combined with subtle, possibly lost techniques has ensured Stradivarius violins remain highly prized and coveted by musicians and collectors alike. Their mystique endures as a pinnacle of artistic and technical achievement. Lycurgus Cup. The Lycurgus Cup, dating from the 4th century AD, is a marvel of ancient Roman craftsmanship that demonstrates advanced nanotechnology centuries ahead of its time. This glass cup exhibits a rare optical phenomenon called dichroism, where it appears green under reflected light but glows a rich red when light passes through it. This striking colour change is caused by gold and silver nanoparticles embedded within the glass during its manufacture. The artisans skillfully manipulated these particles at the nanoscale, controlling how light interacted with the glass material. Such a technique required remarkable precision and knowledge that would remain unknown until the 20th century, making the Lycurgus Cup a unique intersection of art and science. The cup's design illustrates the myth of King Lycurgus entangled in grapevines, linking artistic storytelling with material innovation. Scientific study of the cup helps researchers understand how ancient civilizations achieved complex effects with technological finesse, now linked with modern nanoparticle engineering. The Lycurgus Cup stands as an enduring testament to the ingenuity of Roman artisans and their ability to harness microscopic phenomena long before modern scientific understanding existed. Flexible glass or vitrum flexile. Vitrum flexile, or flexible glass, was an extraordinary material allegedly invented in the Roman era, described by ancient authors such as Pliny the Elder. This glass was reportedly able to bend and flex without breaking, retaining its shape after deformation, an astonishing property unfamiliar in conventional glass, which is brittle and prone to shattering. According to historical accounts, the inventor presented a cup made from this glass to Emperor Tiberius, demonstrating its flexibility by bending and then restoring it. Alarmed by the implications for the glass market, the emperor allegedly ordered the inventor's execution, resulting in the permanent loss of the secret process. This tale underscores how political and social factors can hinder the preservation of technological advances. Modern materials scientists have developed flexible types of glass, such as alkali aluminosilicate sheets used in smartphones, but these require sophisticated chemical treatments and manufacturing conditions unknown to the ancients. The precise formula and production process for vitrum flexile remain elusive, making it one of the most fascinating lost innovations related to early materials engineering and economic impact. Baghdad Battery. The Baghdad Battery, an artifact found near Baghdad and dating from the Parthian or early Islamic period, is a ceramic jar with a copper cylinder surrounding an iron rod. Many scholars speculate that it could be an ancient form of an electrochemical battery capable of producing small electric currents when filled with an acidic liquid such as vinegar. The device's possible use ranges from electroplating small metal objects to performing religious or medical functions unknown to us today. However, the evidence remains inconclusive, as no direct use for this battery has been archaeologically verified. Some researchers argue it might have functioned as a simple container or symbolic item rather than an electrical device. Experiments replicating the battery demonstrate that it could generate enough voltage to power primitive electroplating, suggesting that knowledge of electricity predates modern times. This artifact forces a reconsideration of the timeline of electrical understanding in ancient civilizations. The Baghdad Battery exemplifies the intersection of ancient technology and emerging science, raising questions about archaeological interpretation and lost experimental knowledge. Girolamo Sagato's artificial petrification. Girolamo Sagato was an Italian scientist of the early 19th century who discovered a remarkable process of artificial petrification, capable of converting organic tissues into durable, stone-like material while preserving fine anatomical detail. This technique differed drastically from traditional fossilization or embalming. Sagato's method mineralized biological matter without destroying its original structure, effectively transforming flesh into a stone replica with astonishing preservation quality. His work attracted scientific curiosity due to its potential applications for medical specimen preservation and anatomical study. Unfortunately, Sagato kept his process secret and died before sharing the full method with others, causing the technique to be lost to history. Modern researchers have attempted to reverse engineer his petrification but have failed to replicate the process completely. The mystery behind Sagato's method continues to intrigue historians of science and conservationists, reflecting a unique marriage of chemistry and artistry. His work exemplifies how breakthroughs in preservation science can be lost if not documented or disseminated properly, remaining a puzzle for future generations to solve. Oxford Electric Bell. The Oxford Electric Bell, also known as the Clarendon Dry Pile, has been ringing persistently since 1840, powered by 2 dry pile batteries enclosed within a sealed glass case at Oxford University. This simple device drives a tiny clapper that strikes 2 bells continuously, generating a nearly unheard of energy longevity. The batteries have never been replaced or recharged, yet the bell keeps sounding for over 180 years. The precise chemical composition and design of the dry piles, which consist of metal plates separated by paper soaked in electrolyte, grant extraordinary durability, but the exact reason for such extended battery life remains unclear. Researchers have proposed theories involving extremely slow discharge rates, self-regenerating chemical reactions, or minimal mechanical energy requirements. The bell's ongoing operation defies conventional understanding of battery lifespans and energy degradation. It remains an iconic example of Victorian-era ingenuity and a still unsolved puzzle in early electrical engineering. The Oxford Electric Bell challenges modern scientists to uncover how energy storage and consumption were optimized with simple materials long before modern battery technology. Thank you for watching. These lost inventions remind us how much knowledge has faded over time and how much there's still to discover. If you enjoyed this journey into history's mysteries, don't forget to like, share, and subscribe for more fascinating stories. See you in the next video.